growth. Now this title has already some keywords. Growth, it has to do, I think, with the improvement of welfare all over the world in the sense of satisfying the needs of more customers and of customers in a more intense and a more sophisticated way. This is a discussion we had already for centuries. Adam Smith talked about the wealth of nations. Trade was a source for this increase in wealth. We heard something about this morning by Jeffrey. Capital accumulation is one of the sources of this growth, which then seems to satisfy the needs of the consumers of the households much better. And of course, technological change. And then we are already at the second keyword here, innovation. Innovation is something which drives technological change in a very rough sense. I don't want to go into detail whether this really holds true or not, but let's assume it's okay in this sense. And this topic of innovation is not so long in the economic discussion. It was brought into the discussion by Joseph Alois Schumpeter in 1911 in his book, The Theory of Economic Development, where he highlighted the entrepreneur, the dynamic firm manager, who is able to use new ideas in an economic way and to satisfy his own profit motives, but also the satisfaction of the consumers, the customers who buy the new products or the cheaper products if it's a process innovation. Now, this was brought into by Schumpeter in 1911, and then it took quite some time that the economic profession at the universities and at the research institutes took over this topic more intensely. And I would say until the 1970s, 80s, there is a big surge in this topic, and a large literature came up in a sense, where do innovations come from, how are they implemented into the economy, and what impact do those innovations have on economic structures, economic dynamics, welfare, and so on and so forth. The third keyword here is future. So the organizers want a statement from me, what will be in the future? And this is, of course, a little bit a difficult statement because I can't tell you. I have no clue. I have some educated guesses what may happen, but I cannot give you a definite statement. Fortunately, I'm accompanied by a very prominent colleague. And he, as you can read it here, stated once, it is hopeless to develop a model which will genuinely predict innovations and then all the consequences from that. He continued, if we do this analysis, and we do these dynamic models where innovation activities are included as a dominant or core ingredient, what these models give to you is not any predictions of specific innovations, but an idea of the statistical properties of technological progress. So in a sense, we can maybe predict the degree of fluctuations due to innovative activities. We can maybe say something about the kind of surprises, but not the specific innovations. This is no way. Fortunately, it is Kenneth Arrow who helped me in this context, and so I'm on relatively safe grounds, I think. So I'm not the Oracle of Delphi. Sorry for that. I will talk with some relatively robust statistical empirical evidence, and the longer I talk, the more speculative I will become. Maybe I tell you fairy tales, I don't know. But coming back to Jeffrey's talk this morning, if you invited me in 20 years again, then you can prove whether I had something to say which has a fundament or not today. My talk will have in principle 4 parts. The first part is, what is the welfare situation worldwide today? How did we come to that? Second, what is technological change? What is the contribution of technological change to this state of the world today? Then I will talk about long-run tendencies in technological change. This is already a little bit speculative. And then I will take the next step and say, what may happen in the future? Where do we go to from this point? So let's see whether I can convince you. Let me start first with this welfare growth and the international distribution of income. And I use as a welfare measure the per capita income of a country. I know that this GDP per capita is not the appropriate welfare measure. Stieglitz, Fitoussi, and others always tell us it's the wrong measure. But in order to have a long-run description of that, I would like to invite you to accept this measure as something which is at least correlated highly with welfare. I track this measure over time, and then I will talk about differential growth in the sense that I compare countries in their way how they grow over time, and there's a very prominent hypothesis in this growth theory which simply says that there should be a convergence of the countries in terms of per capita income over time, and the distribution of welfare internationally should be not too large in the end. Now, let me start with a discussion of that, the GDP per capita, from 1950 to recently, 2011 or 12. I selected 4 benchmark countries which will accompany you through the complete presentation. The red one is Italy. The reason is clear, because we are in Italy. If this talk would be in Paris, in London, or in Beijing, then it would be a different country which would be red. And then, of course, United States at one of the pole, Germany, because I have some relationship to Germany, and then Japan as another prominent player in innovation internationally. Now, if you look at this GDP per capita over time, these 60 years roughly, then you see it is an increasing development, so welfare increases over time, relatively parallel, except Japan. There's some overtaking taking place from the last place in the beginning to the second place at the end of this development. The US, in this 4-country comparison, is always the income leader. And as I said, Japan, with a low starting level, shows some convergence to the US. So here, the convergence hypothesis is not really sustained, except for the case of Japan. Now, what you see here already is that at the end of this period, 2007-8, there is a decline of this curve. So that means per capita income is declining a little bit, which means it could be related to the 2007-8 crisis, from which we seem to suffer still today. I will not talk too much about this crisis, because in the end, in my part 3, you will see that for my argument, this 2007-8 crisis is not the major point. There's a different point in my argument, where the 2007-8 crisis is something which is there, we have to accept it, but the principal forces which I look at are much more of a longer duration. Now, I compare these 4 benchmark countries now with a couple of other countries. Here, for example, with other industrialized European economies. You see that you don't have to look at all these country names. What you see here is, in principle, all these curves are increasing, so welfare, GDP per capita is increasing. There is not so much overtaking, except for the case of Norway and Switzerland here, which seem to be higher in per capita income, obviously, than the US, and which was before the income leader. This is for good reason. Switzerland lives off this financial market industry, and Norway had this tremendous oil resources, which made this country at a sudden very, very rich. Again, you have here the 2007-8 crisis, and it's very parallel that all these countries suffer from that. But here, very parallel development, convergence. I would not say it's convergence. Next comparison, now extremely different. I compare now our 4 countries with African economies. And you see there is, at least for this time span, no or very modest growth. These lines are more or less horizontal GDP per capita. There are statistical problems with the data from these countries. This is not to be neglected, certainly. But nevertheless, it is horizontal here, more or less. The gap between the benchmark countries and the African countries is tremendously increasing over time. And only to look here, look at Japan and South Africa in 1950. They started with the same level of GDP per capita. And then these two economies had such a different development pattern in terms of this welfare measure. So they started more or less on the same level. That is interesting and needs, of course, explanation. Next comparison is with Latin American economies. You see a very similar picture here as in the case with African economies, although the Latin American economies have a higher per capita income than the African countries. But also since the 1970s, the income gap towards our 4 benchmark countries is increasing tremendously. There are some economies here and there which perform better, Venezuela, for example, because of oil reserves, or Chile in the end of this sub-period here, 2005, has an uptake. So there is some development there. It's not completely horizontal, but the gap between the 4 benchmark countries and these Latin American economies is also tremendously increasing over time. Let's come to Asian economies and the tiger states, the prominent tiger states. Now here the picture is a little bit different. You see there the gap is not always increasing. You see that there are at least 4 tigers, Singapore, Hong Kong, the upper level, and Taiwan and Korea, which were able to catch up in per capita income from very, very low levels into the region of Italy or even the US and higher. So these countries were very, very successful in showing a convergence, if not overtaking, if you consider Singapore. There are some countries which recently seem to show a takeoff, Malaysia, Thailand, and China. But, and this was also a point this morning when Jeffrey gave his presentation, on a relatively modest, very low per capita income level. The Chinese economy in total with 1.3 billion population is, the GDP is very large, but per capita it's a relatively low level still, but it seems to increase. Last comparison, because we have now roughly 25 years of the fall of the wall, then we can also look at European transition economies and compare them with our 4 benchmark countries. And there you see that a lot of them show some convergence, show some catching up to our 4 benchmark countries. So there seems to be something going on which helps these countries to improve their per capita income over time and even to catch up to the benchmark countries here, prominently Slovenia, the Czech Republic, or Estonia. Now, if you try to collect these developments all together into one graph, then you can derive this distribution curve here. And this distribution curve is something where you plot the income level increasing from the left to the right, the per capita income level. And you do this for different years. I hope you can see it. You can see it, I think, yes. And you see here 4 different lines. It starts with a bold line, and then it becomes more and more dotted lines from the 1960, 1970, 1980, and 1990. And what you see on the right-hand side is that there a second peak is emerging. At first you have one peak and it slows down, but now on the right-hand side a second peak is emerging. And this tells us that there are 2 clubs of countries. Some which, on the left-hand side, which are relatively low GDP per capita, and a large number of them, because this peak is that high. And on the right-hand side, a smaller club of relatively high GDP per capita countries. This is the situation 1990. This separation of the world economy in these two clubs has a lot of consequences, and it might be, I don't want to go into detail with that, but the problems we have these days are also related to some degree to these big differences in GDP per capita in these two clubs of countries which emerged over time. Now, the question is, why did it happen that way? Why did the convergence hypothesis, which was so prominent in the 1960s, countries would converge in per capita income, why did it not show up? What factor got neglected, was not seen in the analysis? And one of these factors, which is a very prominent one, is technological change and innovation activities. Now, in the 1960s, 70s, we had an exercise which we called growth accounting. That was an exercise we said we want to understand the growth in GDP or in GDP per capita dependent on how many inputs an economy is using in order to produce this GDP. And out of this analysis came a residual term, something which was left over in this equation, and Mo Abramowitz called it our measure of ignorance. There is something which we cannot understand, we cannot give it a name, let's call it our measure of ignorance. And this is so-called total factor productivity. Over time, there were a lot of analysis in order to understand what it really is, so that the ignorance is not an ignorance anymore, but more something we know. And today we could argue that this total factor productivity, which is often used, the variable A, you can interpret it as the ability of a country to produce outputs by inputs. This ability can be very high, very sophisticated, but this ability can also be relatively low, not so sophisticated. And therefore, you can use this measure as a measure of technological sophistication or the technological level an economy uses in order to produce GDP. Then you can track the change of A over time, and then you can interpret that in a very rough and loose sense as a measure of technological change. I will use this measure, but since most of the statistics in the literature you find use an alternative measure, it's called labor productivity. This is simply very similar to GDP per capita, but it's GDP per labor force. Or if you measure labor force in hours worked, even the better. So it's not exactly the same measure as GDP per population, per capita, it's the GDP per labor force. We can also use this labor productivity and its level as a measure for technological sophistication and the change of that labor productivity over time as a measure of technological change. The specific assumption has to hold that these two measures are the same. The assumption is that the relationship between capital and output is always the same, it's constant over time. Whether this holds true or not, on the macro level it's quite fine. On the disaggregated level you have problems in order to justify that. But I'm arguing only on the macro level, so I'm hopefully on safe grounds. Now I interpret these two measures as technological level or as a technological change when I look at the change. Being aware that both measures can be influenced by a lot of other factors than technology or innovations. The size of the production, natural resources, whatever. All those factors can, of course, have a big influence on these measures, but I assume that the most important influence is simply technology and technological change, is innovation activities. Now, let me start with total factor productivity. Be careful with this graph here. This measure of total factor productivity is country-specific, where I start for each country in the year 1985 and set the level of TFP to 100. And then I track this over time. So you can compare these different curves, not by their level, whether they are higher or lower, but only by their change. So you see here, it is Korea which has the highest curve. This is not to be interpreted that Korea is the technology leader. It simply says that the development of this measure for Korea is higher than the development of this measure, for example, for the US or for Germany or for Italy, for those countries. Yeah? So, for all these countries, the TFP development is positive, mainly positive. Look at the red line. For Italy, starting roughly in 2002, this line has a negative slope, slightly negative slope. And the next slide will be better, don't worry. Better than the outcome. Now, if you look here, if you say the technology or the income leaders, US, Japan, and Germany, they are in the middle of this block here. They have a relatively modest level and change then of total factor productivity. This seems to be the fate of the technology leaders. To shift the frontier, the technology frontier, is very, very hard. It's very difficult to do that because you go into a new territory, into new lands. And this seems to be very difficult. If you compare that, for example, with these high flyers here, Korea, Ireland, or Finland, which is high curves, they do much more easy to improve their total factor productivity. And this has to do, first of all, they can learn from the leaders, imitate, learn from them, and they were successful in investing into knowledge-based capital. And knowledge-based capital is a core concept here. I define knowledge-based capital as everything actors do in order to get more knowledge, more insights, new ideas. This could be R&D, this could be patents, this could be building up human capital. All those activities contribute to a concept, a very rough concept, a very agglomerate concept of knowledge-based capital. And this knowledge-based capital is a core element in this innovation-driven development for the following reason. In this knowledge-based capital, in this space of knowledge-based capital, you as an actor, you cannot jump easily upwards the ladder. It's not easy. And you cannot make big jumps. If you want to develop your knowledge, then this is an accumulative process. You do it step by step. You have to learn, you have to experiment. Even if you imitate from the leader, this is also not an easy task. It's not a simple take it over the knowledge. You have to understand this knowledge. So it's time consuming, it's resource consuming in order to do this. And by this cumulative nature, if you have two actors, two countries, which start at a different level of their knowledge-based capital, the one who is leading is often very much easier to improve than the one who is following. And by this, you create differences, you create gaps between these actors, between these countries, which cannot be so easily closed. And this is the reason that now we have leaders and we have followers. Now, let's jump over to labor productivity, because this is the most used indicator for this kind of discussion. Now I have here again those countries, and now you are allowed to read these curves in the following sense. The curves which have a higher level, these are better performing countries with a higher technological level, with a higher knowledge-based capital. And in this sense, for example, for a long period from 1970 until roughly 2000, the US is the technology leader in the world. Then you see by this narrow violet line, Norway is taking over. Norway is now, for the last 2 decades, Norway is the technology leader. Other countries follow. You see the US and Norway, they built over this time span the technology frontier of the world. You see that we have catching up economies. Here the BRICS, where you see the BRICS, the 5 letters are, 4 of them are red, one is black. Black is India. India is not catching up, but the other economies in this graph here, they are catching up. So they are able to learn from the frontier and can try to close the gap towards the frontier. You see for the European countries there's not so much catching up going on. They are relatively parallel in their development. Again, here the knowledge-based capital is a core variable, which leads to these differences, to this heterogeneity among the countries. You see also here that in some countries there's a slight drop after the 2008 crisis. Narrowing down this world view now to a European view, then you see here 6 European countries as examples. You see that they develop relatively similar, relatively parallel. There's a drop in 2008 with respect to the reaction to the probably the financial crisis. Now, I told you the welfare is very unevenly distributed over the world. It has to do with these growth processes which take place, in my example, from the 1950s. And when you include technological change, which is based on knowledge-based capital, which has to be accumulated by the countries, in a way I described, then you find this divergence in the welfare. You find that. Where does this lead to? Will we have even more 2 clubs, or maybe 3 clubs of countries, the very, very rich ones and the rich ones and the very poor ones? How can we think of that? How will this develop into the future? Oh, sorry. Section 3, where we come from, long-run tendencies. I go back to the total factor productivity indicator, but now the rate of change, the growth rate of this indicator. A lot of countries, inaccessible curves here, not easy to interpret, but roughly you have a slight negative development. Over time, at least since 1985, the growth rate of TFP is declining. In the aftermath of the 2008 crisis, it's even negative for some countries. You see here, but it's declining. Can we consider this as a slowdown of technological change? Can we interpret it in this way? The same exercise for labor productivity, the growth rate of labor productivity. Even more pronounced here, the line, the curve, or the period here is already starting in 1971. There is a negative development. Productivity change is positive, but the rate is becoming smaller and smaller. From 10% in 1971 roughly for some countries, going down to close to 0%, if not negative for this 2008 case. Slowdown of technological change. The European view, again, you have the same picture, very, very parallel what the European economies here experience over time. And even if you look at the different European areas, 18 countries, 15 countries, 28 countries, and so on and so forth, you also find on this average level a declining rate of labor productivity growth. This is called the so-called the productivity slowdown. And how can we interpret that? I interpret it in the following way. At a certain point in time, to the economies, they were given technological opportunities which were not exploited, which were very rich. You only have to become active to exploit them. In the beginning, to exploit them was relatively easy. But by the degree that those potentials become exploited, each next step to do it becomes harder and harder. You have to invest more resources in order to exploit them. So it becomes more and more difficult, more and more risky, let's say, also to invest into those activities. Now, how is this productivity slowdown now in this view? How is it interpreted? There are several views on that. There's a pessimistic view, which simply says, this is a permanent development leading to stagnation and growth, and this will be enhanced by factors like demography, inequality, environment, debt, and so on and so forth. So this is something, this is our fate. We will run into this trap and then we will stay there for a very long time, let's see, at least. There's an optimistic view. It says, despite this productivity slowdown, the underlying rate of technological change has not slowed down, and ICT will continue to dramatically transform frontier economies. So it's something, maybe it's a measurement problem or something like this, but don't worry, we will get out of this trap. This should not be a big problem. I have more different view than the pessimistic or the optimistic one. It's of course, you have the one, the other, then the middle is probably correct. It's a view of a challenge, and I suggest here the productivity slowdown is an indication of a secular development with exploited current technological opportunities and the prospect of renewed plentiful opportunities for all and not only the former frontier countries. So we are in a situation where we have exploited to a large degree the concurrent opportunities, but there will be new opportunities at the door. We only have to get there. Is this position convincing? You will tell me later probably. Let's look at that. I first show you now some indicators which should inform us that current technological opportunities seem to be more and more exploited. I look now not at productivity measures because they are so rough that I do not find much more as I had shown you before. Now I really look at concrete indicators for innovative activities. I start with research efficiency. And I have here an indicator which tells you if you invest 1 billion business expenditures on R&D, how many patents on the average do you get out of this investment? You see it here for a couple of countries. And you see it starts 2003. These curves are declining. That means research efficiency is going down. Or put it differently, in order to have one patent, over time you have to invest more and more into getting it. It becomes more costly to invest into research which leads to a patent. You see the frontier country, the United States, has the lowest efficiency in that, which is not so surprising because if you are on the frontier and you cannot imitate, then it's the hardest way to go for it. If you can imitate partly, then it's more easy to do this. However, I'm fully aware that the patent indicator is here a problem because it's a count indicator here, 1 patent, 2 patents, 3 patents, and the quality of the patent, the importance of the new knowledge which is written down in the patent is not taken into account. So take it carefully here. So one has to be, it's taken with caution. Interesting is that these negatively sloped lines occur despite we have a surge in patent applications of the last 20 years. So if you compare that with the 1980s or so, the number of patents applied worldwide has increased tremendously due to also changes in the patent laws. So if it becomes harder and harder to get a patent, to have to pay more, this could be an indication that opportunities got exploited. Secondly, now I have to restrain my analysis very much. I can only go to Germany because I don't have the data for other countries. It's very similar as I have seen for Denmark, but for the other countries, as yet I don't have that. Now I look the share of innovative firms in all firms of an economy here for Germany. Now I look into research-intensive industries, in other industries, in knowledge-intensive services, and then it's cut here, unfortunately, and also in other service industries. And if you look at this line, then you see, at least since 1997, these lines are declining. That means the share of innovative firms in all firms becomes smaller. And please be aware, this tendency started already before the financial crisis 2008. It's something that started before. It might be accentuated after 2008. This I would not deny. So some of the curves becomes more negatively steep, but it started already before. So, and after 2008, surprisingly, this took place also in Germany. We had a relatively prosperous economic development and we had very easy credit conditions. So it's not something that the economy is so weak. It's something which has to do with the willingness of those actors to become innovatively active. Now, you might argue maybe this is a composition effect. In one industry, innovative activities slow down, in others they increase. I split these indicators up here and looked for manufacturing for a couple of industries. You see them on the right-hand side. But for all these curves, they have a declining pattern. So the share of innovative firms is declining over time. Less and less firms are willing or successful. I cannot distinguish between the two, are successful in creating new ideas and out of that new products, new processes, and so on and so forth. So there's no composition effect, it's a general effect which affects all industries in an economy. If you do the same for services, you find also a negatively declining line here. By the way, if you look carefully, except ICT and telecommunications, this is more horizontal. So there, this seems not to take place. But for the other services, it's totally clear that it's also negatively inclined. This share of innovative firms in all firms does not distinguish between large and small firms. However, in the economics of innovation in the literature, it's since Schumpeter's writings, it's a big issue whether small firms or large firms are the more innovative ones. And this depends, the answer is not straightforward. It depends on the context. But in principle, there is one statement which certainly holds. Small firms stand more for radical innovations, where big firms, for reasons of efficiency of investment and so, stand more for incremental innovations. Now I look here at new firm formation and also of the development of young firms in the economy. Now again here for Germany, we have new firm formation and we have the stock of young firms. New firm formation is the blue line. The stock of young firms is the red line. And you see already since 2005 the declining development. Less new firm formation, and as a consequence of that, certainly the stock of young firms is declining because young firms become older and then they leave the club of young firms and jump over to the club of older firms. So also an indication that there is not so much incentive anymore to found a new firm, maybe based on a new idea, on a patent or something like that. This also started already before 2008. Going out of Germany, going to the United States, looking at young firms, high-tech young firms. If you look at the red line here, you see this red line is declining certainly since the year of 2000. Less and less young high-tech firms in the economy, in absolute terms. If you look at the share of young high-tech firms in high-tech sectors, the red line, this share is declining since 1982, with a little trend reversal between 1997 and 2000, but in principle a negatively inclined development. The same holds for small share of young firms in all industries, from 50% going down to a little bit more than 30%. Again, the same indication. Those actors which seem to be responsible for radical innovations, we are more likely to have radical innovations, those actors become less in absolute and in relative number. Canada, last example for that. You see here entry and exit rates into markets or industries. You see that both lines, red is the entry rate, blue is the exit rate, both lines are declining. This tells us that the structure of the industries, of the economy, becomes more and more stabilized. We know this from industry life cycle analysis, that an industry gets born at a certain point in time, it develops, and after 30, 40 years, not much more young firms enter, not much firms have to leave. So you stabilize the structure of an industry. And this is in industry life cycle also connected to less numerous and less radical innovations which come out of that. Here it seems to be the same picture in a way. not for an industry, but for the economy of Canada at all. A stabilized structure where you cannot expect too much radical innovations coming out. Again, Canada, now the blue line is the number of new entrepreneurs. This is an important line here. You see, since 1989, a declining number. Less and less actors are willing to jump into business based on usually a new idea. If you take this all together, which is a scattered evidence, certainly, I have not covered all countries, all industries, certainly scattered evidence. This could be a nice indication that there were high technological opportunities in the 1970s and 80s, and we exploited them by our activities over time, and it becomes harder and harder to do additional new steps. And therefore, these activities decline over time. The pessimistic view, as I said, is this will continue. We are in the trap. The optimistic view is we measured it wrongly. And my view is there is a challenge because there is something ahead which we may want to see. We only have to go there. And where we go to now. What I use here is the theory of long waves. Some of you will be now surprised, even if not irritated. Don't worry. I take this theory of long waves metaphorically. I know that it is statistically not proven that it works this way. If you ask economic historians, they tell you more or less always the same story. It's something like that, but statistically it's not robust for the very reason that the data, in order to test this, they are not there. We don't have them. But in principle, this theory tells you the following. Innovation activities are not spread evenly over time. You have periods where innovation activities cluster tremendously, and you have other periods where those activities are very low in number. And this clustering is related to the upcoming of very dominant technologies. There are various names for those technologies. I call them now general purpose technologies. These are technologies which can be used by a lot of industries, by a lot of actors, and they are not specific to only the one or the other firm or industry. I call them general purpose technologies, and they characterize this development. We have then certain cycles. You see them here. You see also that this development is also connected to crisis. This is a topic I don't want to go into now. It's a very interesting phenomenon, and if you read the book of Barry Eichengreen, The Hall of Mirrors, then you see something like that, the discussion there. I have to skip that here. It takes another hour. You don't have the time, and I will be given the time. Now, this long wave research simply tells you that these basic innovations or these general purpose technologies are very much correlated with economic development. Schumpeter brought the discussion up in his book Business Cycles 1939, where he identified, at least theoretically, the clustering of innovations and the swarm of imitators. And Freeman and Luther in the book As Time Goes By exemplifies that very nicely, how this worked over time since the Industrial Revolution. There are two streams of research, one led by Mensch and Kleinknecht, and the other one by Clark, Freeman, and Sute, which suggest that if a certain general purpose technology gets exploited, the economy runs into a depression, a recession. And then activities of the actors will be reoriented in order to find a new general purpose technology, which is not easy to do. This is very difficult, it's very hard to do this, but there is a chance. And they simply suggest that it's a depression trigger hypothesis. That means the depression triggers those activities to find a new general purpose technology. And then radical innovations will come up again. I use this in order to tell you what could be the future of economic growth. I do it now in 4 steps, very briefly. First, there are promises around in the world. We have these general purpose technologies which are characterized by general applicability. They are technologically dynamic. They are always further and further developed. And they are innovations spawning. That means they affect a lot of other industries. So there's a sense of a network in some degree. And we have examples. The black ones are those from the the long waves we had in the past. The steam engine, the dynamo, plastics, computer chip, and so on and so forth. And the gray ones are those which might be ahead in the next decades. The robot, Industry 4.0, digitalization, for example, or intelligent materials, nanotechnology, something like this. They are ahead. One could envisage them. They are not as yet really established, but one could see them that they are around. Technology and innovation policy is, of course, one initiator of that. This year is the German high-tech initiative, which I know relatively well, where the ministry set up a plan what kind of not as yet well known directions of technological change will be furthered. Here you have the examples: digital economy and society, sustainable economy and energy, innovative workplace, and so on and so forth. They define certain areas. Behind that is a societal need. And they simply say, if you go into this direction, then we will sustain that. These could be general purpose technologies in the future. Which one? Don't ask me, I have no clue. But maybe some one of them will be. So we have promises. We have opportunities for that. And here I want to bring into the discussion the concept of windows of opportunities also for lagging economies. The issue is the following. In the old general purpose technology, this knowledge accumulation provides for differences between countries which cannot so easily be closed. But with a totally new direction into a new general purpose technologies, the knowledge you accumulated for the old general purpose technology, I exaggerate a little bit, is depreciated. You cannot use it anymore. You have to build up a totally new stock of knowledge. And this provides that even lagging countries are now on the same level with you, roughly the same level. I would not deny that those who are in lead today have also star advantage. But in principle, you bring them on the same line. So it's not that only the big technology leaders of these times have a chance, but also other lagging countries. Is there some evidence for that? There is. I look now at frontiers, technology frontiers, but not on the country level. I look on frontiers worldwide on the firm level. This is an exercise for all relevant industries, the 100 in labor productivity best firms tracked over time. Some of those firms are at the frontier, some of them are lagging behind. So you can distinguish between frontier firms and non-frontier firms. You can track them from 2001 until 2010. And you see that the line for the frontier firms in both, in manufacturing as well in services, is much higher than the red line of non-frontier firms. So, and you see that the non-frontier firms, they have a decline over time in their productivity development. There's a curved, the U-shaped curved development, whereas the frontier firms have a steadily increasing development. That means those frontier firms are able to persistently increase their labor productivity. And the clue now is the following. These frontier firms are not only from the US, Europe, and Japan, they are spread all over the world. You have firms here from India, from China, even here the one or the other Latin American firms. That means there you have their firms which could be technology leaders. Maybe we have also to change our view a little bit. It's not the countries which makes the story, but it's the firms which makes the story. In a globalized world with multinational firms, maybe it's even not so sensible to talk about companies, but about firms. But this tells us that these opportunities are open now to more and more countries because we have more and more firms which are on the frontier from different countries and not only from the US or Europe. Some water in the wine. The frontier firms become, unfortunately, older and older. Older and older means larger and larger. Large firms are not so much responsible for radical change. So there's some water in the wine. But nevertheless, I have some hope that a lot of countries now can start via their firms to be at the technology frontier. Reachability and feasibility. The change from one general purpose technology to the other is a system change. It's not a change which one actor, one firm can do alone. Consider this graph here. I hope it's insightful. You have a technology blue, this is the old one, and you have a new technology, GPT, which is the red one. And you see this by this blue dot. This is the old technology. Over time, it developed into a relatively low price per unit of the output it produces. Now there is a new GPT at the horizon, and you want to catch it. And this new GPT promises you to have even a lower price than the blue price. But to get there, you have to climb up this hill, and then you can use scale effects and something like that. So to change from one GPT to the other, in cost or in price terms, you have first to climb up a hill, and then you can go down to the new, let's say, equilibrium there. And climbing up this hill, it's not one firm, one actor who can do this. This is a collective process. A lot of actors have to work together in order to accomplish that. Most prominent in this concept are small and new firms. The old firms usually are not so not so willing to do that. But small firms go more for this radical change. And you need political actors in order to get the system over this little mountain here. Now, this leads me to the policy debate. I'm close to finish. There are policies around already. We have a policy which is called new mission orientation. This is just what the new high-tech strategy in Germany is doing. They look at societal problems and say, we will subsidize activities on a broad range in order to cope with the societal problems. They give orientation. They take out uncertainty for the firms because they know there is someone who is fostering that. We are fine with that. New mission orientation. Then we have policies like smart specialization. That's a regional concept which is said in order to bring a region up, you need small firms which are able to anchor the technological development of that region into a concurrent general purpose technology. Do this, then your region will be prosperously developing. Mazzucato, a name which should be very prominent in Italy, Mariana, she is propagating the entrepreneurial state. The state should do it now in order to go from one GPT to the other. The state is the actor who can do this. And my stance is more this catalytic Schumpeterian policy. That means try to bring all the actors at the top of this little hill. From then on, they can walk alone. It's a policy mix which has to be implemented. You have to have push and pull instruments. We exemplified that for renewable energy transitions. It's a Schumpeterian push, foster innovative activities. It's a Keynesian pull, create the demand for those technology, because the demand is also a problem. Create the demand, so they will pull you. They will pull the actors, and then you will be able to master this little hill. Concerns. You asked me to talk about labor. One concern with these new developments is radical and systemic change a threat for employment? That is always a concern. What do we do? Substitution of labor by machines. Does it really hold true? I cannot give you a good answer. I can indicate that in the short run, if you have a new technology, you have creative destruction. This is unavoidable. Some firms will have to close down, employees will be unemployed. This is unavoidable. In the long run, demand and growth effects can compensate for that. I'm very optimistic. The history showed us that it works that way. But in the short run, you have unemployment. This is no doubt. Secondly, technology substitution versus technology complementarities. It depends on the new general purpose technology, whether it's more substituting concurrent technologies or whether it's a technology which is more complementary to other technologies. In the second case, unemployment is not so much a problem. If it's strongly substitutive, unemployment might become a problem. Policy may be able to work against that. Last but not least, which employees are threatened? The literature by David Author and colleagues is Those who do routinized work, they are threatened. Those who do analytical or creative work are not so much threatened. Policy can do something against that. Educate your population in a way that they are not only routinizedly working, educate them in the way that they are able to be analytically and creatively working. If you can do this, then this is some kind of a protection against this threat of new technologies. To come to an end, I could now, of course, easily summarize in 10 minutes what I said, but I will summarize or conclude in a different way. Yesterday, when I came here to Bologna, I was interviewed, and one question was, what role do you foresee for Europe in the world and for Italy in Europe in 40 years? In view of what I told you in the last minutes, whenever Europe will be able to coordinate innovative and entrepreneurial activities with research at universities and research institutes, and with a policy mix towards technology, demand, education and employment, the radical systemic transition has a high chance to be successfully mastered. Then we might be able to cope also with these strong machines like China, for example. I was last week in China. It's impressive what they do. And they coordinate. So if we can coordinate that, then it would be helpful. We had this morning a political discussion about how to coordinate Europe. I agree what was said, but this has to be solved. Otherwise, this statement will not hold true. So this problem is something which is tremendous. Secondly, the question for Italy. Since small and medium-sized firms play a big role in this process, countries with an appropriate industry structure may have an advantage. Italy. Thank you very much.